This is a response video to the rubber band ant puzzle given in the Rest is Science podcast, linked in the description. So Hannah's puzzle goes like this. You have an ant sitting on one end of a 10 centimeter long rubber band. After 1 second, the ant walks forward 1 centimeter, and the rubber band stretches to 10 kilometers. On every subsequent second, the ant again walks forwards 1 centimeter, and the rubber band stretches another 10 kilometers. Hannah asks, does the ant ever reach the other end? At first glance, this feels impossible. The ant moves forwards by just 1 centimeter each second, but the rubber band stretches by 10 kilometers each second. So it seems like the finish line is pulling away faster than the ant could ever catch up. But there's a better way to think about this. Instead of tracking the ant's distance, we should track the fraction of the band that it has covered. Here's the key idea. When the rubber band stretches, the ant does not lose progress in terms of percentage completed. Because the stretch happens proportionally, the part behind the ant stretches and the part ahead of the ant stretches by the same factor. So if the ant is 30% of the way across, after the stretch, it's still 30% of the way across. That means the only time the ant actually makes progress is when it walks forward. So we can define a new quantity, W of t, to be the fraction of the band covered after time t. Now let's compute how much progress the ant makes each second. So on the very first second, the band is only 10 centimeters long. The ant walks forwards 1 centimeter, so it covers 1/10 of the band, which is actually a huge amount of progress right away. But then the band stretches to 10 kilometers, which is 1,000,000 centimeters. So on the next second, the ant walks forwards 1 centimeter again, which is now just 1/1,000,000th of the band. Then the band stretches again, and now it's 20 kilometers long, and the next step contributes to 1/1,000,000ths of the band, and so on. So after t seconds, the total progress looks like 1/10 plus 1 over a million times 1 plus a half plus a third, all the way up to 1 over t minus 1. And that expression in the parentheses is the harmonic series. The harmonic series is defined to be the sum of the reciprocals of the natural numbers. And it's a pretty well-known result from calculus that even though the terms keep getting smaller, the sum actually diverges to infinity. And since the ant's progress includes this growing sum, its total progress also keeps increasing. Eventually, it passes 1, which means the ant reaches the end of the rubber band. So, how long does this actually take? To estimate this, we can approximate the harmonic sum with the natural log, and substitute with log of t. When we solve the equation, we get that t equals e to the 1,000,000. So, yes, the ant will eventually get there, but not anytime soon. We can also look at a continuous version of this problem. So, instead of moving in discrete steps, imagine the ant walks smoothly at 1 centimeter per second, and the band stretches continuously at 10 kilometers a second. At any moment, the ant's fractional progress is its velocity divided by the total length of the band, which is 10 plus the product of the stretching rate times the time. If we integrate that expression using U substitution and do some algebra, then we'll get a formula for the time it takes the ant to reach the end of the rubber band. And that formula has the same form as in the discrete case, where it grows exponentially in the stretching rate. So once again, the time is finite, but it's a huge amount of time. Let's build some intuition for why this actually works. At the beginning, the relative velocity between the ant and the end of the band is positive. So the end of the band is moving away faster than the ant's 1 centimeter per second walking speed. So early on, the gap is definitely increasing, but much later, the situation changes. So let's imagine we're in the discrete case and that the ant is, at this point, extremely close to the end of the band, and say that there's only 2 centimeters left. The ant walks 1 centimeter, so now only 1 centimeter remains. Then the band stretches, but by this point, the band is already unbelievably long, so adding another 10 kilometers only changes its length by a tiny percentage. So that 1 centimeter gap might only grow by a very small scaling factor, let's say 1.01 centimeters. Meanwhile, the ant is still moving forwards at a full centimeter per second. So eventually, the ant's forward motion becomes larger than the growth of the remaining gap. And from that point on, the gap actually starts shrinking. That's when the ant really starts to win. So the key idea in this puzzle is that absolute distance is misleading, and what really matters is the fractional progress. And because that progress adds up like the harmonic series, which grows forever, the ant eventually reaches the end. It just takes an absurd amount of time. For a fun challenge, try figuring out exactly when the distance stops growing and starts shrinking. Leave your answer in the comments, and thanks for watching.